In Module 6, Lesson 12, we're going to start describing the center of a distribution using the median. As you may recall, the median is the middle number if you put the data set in order from least to greatest. If there are two middle numbers, it would be the average of those two. In example 1, we're asking you to suppose a chain restaurant, which we'll call Restaurant A, advertises that a typical number of French fries in a large bag is 82. The graph shows the number of French fries in selected samples of large bags from Restaurant A. You just bought a large bag of fries from this restaurant. Do you think that you have 82 French fries? Well, in looking at our dot plot, first of all, if we go to 82, there were no samples that had exactly 82 French fries in them. As a matter of fact, there were no samples that had even 81 or 83 French fries in them. So the likelihood that you have a bag of fries that has 82 French fries in is very unlikely. Next, we want to look at how many bags are actually in the sample. So when we count each individual dot, which represents a piece of data, we find that there are 20 bags in the sample. Finally, we're going to look at the statements that are made and decide which of them would seem to be true given the data that's in the dot plot, and then explain our reasoning. Statement A, half of the bags had more than 82 fries in them. So when we count the number of bags that have more than 82 fries in them, we find that there are 10 bags out of 20, which would be half. So that is definitely true. And then statement B, half of the bags had fewer than 82 fries in them. And when we go back and count, we find as well that there are 10 bags that have less than 82 fries in them as well. Statement C, more than half of the bags had more than 82 fries in them. Well, that is not true because there are exactly 10 out of 20, which is 1/2. Same way with statement D, more than half of the bags had fewer than 82 fries in them. That is also not true. Then finally, statement E, if you got a random bag of fries, you could get as many as 93 fries. We do have one bag of fries that had 93 fries in them, so it is possible that if we got a random bag of fries, it could have as many as 93 French fries in it. Okay, so remember when you give written responses, make sure you include in them the things that we discussed that were true about these three statements. Sometimes it's useful to know what point separates a data distribution into two equal parts, where one part represents the larger half of the data and the other part represents the smaller half of the data. This point is called the median. When the data are arranged in order from smallest to largest, the same number of values will be above the median as are below the median. Suppose you were trying to convince your family that you needed a new pair of tennis shoes. After checking with your friends, you argued that half of them had more than 4 pairs of tennis shoes, and you only had 2 pairs. Give another example of when you might want to know that a data value is a halfway point, and explain your thinking. One place where it is nice to be able to argue your point would be when you were talking about how much other people earn. You would want to try to have at least halfway. You don't want to be on the lower half of that data. Now, thinking back to the information in the dot plot in example 1, the median number of fries was 82. We want to know how many or what percent of the bags have more fries than the median, and then what percent has less than the median. So we'll just look back at our dot plot. Remember, the median is 82. And that was the number that we compared in all of the questions in exercises 1 to 3. That would mean then that 10 out of 20 have more than 82 French fries, and 10 out of 20 have less than 82 French fries in them. And 1/2, 10 out of 20, is the same as 50%. 50% have more, and 50% have less fries. Now let's suppose the bag with 93 fries was miscounted, and there were only 85 fries. Would the median change? Again, let's look back at our dot plot so we know what we're looking at. If the 93 became 85, it would still be in the group that is more than the median, which is 82. So the median would not change, since 85 is still in the group above 82, which is the median. Now let's suppose that the bag with 93 fries really only had 80 fries. Would the median change then? Now the median would change in this situation since 80 is below the median of 82. And that will make it 11 out of 20 below 82 and 9 out of 20 above 82, which means that 82 would no longer be the midway point. Some other number would have to take its place. The owner of a chain, of this chain, decided to check the number of French fries at another restaurant in the chain. Here's the data for restaurant B. First of all, how many bags of fries were counted? So when you count the number of bags, you find that there are 19 bags. Sally claims the median is 75, as she sees that 75 is the middle number in the data set listed above. She thinks half of the bags had fewer than 75 fries. Do you think she would change her mind if the data were plotted in a dot plot? Well, first of all, 75 might be the middle number in this list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 9 pieces this way. But this list is not in order from least to greatest. And the median is the middle number when it is in order from least to greatest. If Sally plots the data set on a dot plot, it would automatically put the data in order, so that would help Sally find the actual median. Jake said the median was 83. What would you say to Jake? So 83 is the most common number of fries in the bags. 5 bags actually had 83 fries. That makes it the mode, but it is not in the middle of the data, which marks where the number of bags with fries more than and less than are the same. Betsy argued that the median was halfway between 60 and 85, or 72 and 5/10. Do you think she is right? But Betsy is wrong, because the median is not connected to the distance between points on the number line, but it's connected to finding a point that separates the data into two parts with the same number of values in each part. Chris thought the median was 82. Do you agree? Well, Chris is correct. Because if you order the numbers, the middle number will be the 10th number with nine bags that have more than 82 fries and with 9 bags with fewer than 82 fries. One final time, let's look at the data set. And let's make sure that we order them from least to greatest. So our data set ordered from least to greatest is in bold. And then we can count and we can see the middle or the median number, which is 82. If we then calculate the mean and compare it to the median, we'd find the mean is 78.6. And remember, the mean is when you add up, find the sum of all the numbers, and divide by the number of numbers. Where the median is the middle number. That's what we've been working with during this lesson. Median is the middle number, which we found to be 82. The bag with the 60 fries, we look back there, the bag with the 60 fries really lowered our mean because it is so much lower than the other values. And that's why our mean is so much lower than the median. In our last group of questions, we're using a frequency table to get our data from. So this third restaurant, Restaurant C, tallied a sample of bags of French fries and found the results below. The number of bags that they counted was 26. You count all of the tally marks in your frequency table. So there were 26 bags. The median number of fries for the sample of bags from this restaurant, and this data is in order from least to greatest. So if there are 26 bags, we would need to find the average of the two middle numbers. And that would be 26 if there are 26 pieces of data, then halfway would be 13, which would be in between 79 and 80. So there are 13 lower than that value and 13 higher than that value. So in between 79 and 80 would be 79.5. So our median for this set is 79.5. Which is halfway between the data values. Robert decided to divide the data into 4 parts. He found the median of the whole set, which is 79.5. He listed the values of the bottom half and then found the median of those 13 values and did the same thing with the top half. So the bottom half values are listed, and the median of those 13 values, and then the top 13 values are listed, and the median of those. These values will come in very handy as we start to work on box plots. Which of the three restaurants seems most likely to really have 82 fries in a typical bag? Well, restaurant B seems to have the most bags closest to 82. Restaurant A goes from 87.5 to 75 fries, so there's a pretty big gap there. And restaurant C goes from 78 to 84, but the median is 79. So it kind of looks like restaurant B. Be most likely since the median is 82. Recall that in this lesson you learned about a summary measure for the set of data called the median. To find the median, you first have to order the data, put it in order from least to greatest. The median is the midpoint for a set of ordered data, and it separates the data into two parts with the same number of values below as above that point. For an even number of data values, you find the average of the two middle numbers. For an odd number of data values, you use the middle value. It's important to note that the median might not be a data value, and that the median has nothing to do with a measure of distance. Medians are sometimes called a measure of the center of a frequency distribution, but do not have to be the middle of the spread or range of the data.